Hello and welcome to Finextra. I'm Emily Horler and I'm here with Rob Palatnick of DTCC. And we're at Cybos 2016 in Geneva. Thank you very much for joining me.
Thank you, Emily.
So what do you see as the main practical applications of distributed ledger technology?
There's a number of different ways we believe the applications will come out of distributed ledger technology, but those will probably come out over time. Really, it starts with the fact that the technology itself is this distributed database of information that is secure, it's encrypted, but it's shared in near real time. So there are a number of different applications where sharing information among multiple parties makes a lot of sense. We've heard of examples like proxy voting, communications between corporations and investors. This is a corporation needs to communicate with many different investors in a number of different ways and ensure that there's private channels. That seems to make a lot of sense, and there are really a variety of different applications across the financial industry that could benefit from this type of information sharing. Reference data is an example of something that comes up relatively often. And inside of DTCC, we're pursuing two different cases where information sharing about transactions in near real time, repurchase agreements in US Treasuries, and credit default swaps, and sharing that information among the multiple parties involved and with regulators is having a lot of value. I believe that the implications of that is going to be to reduce the multiple layers that exist today, so that the different technologies that exist to transfer information between parties, to translate it into different database formats, all of those will be able to be eliminated, but it will take time. So I think rolling out the technology, seeing some pilot programs work and proceed, some succeed, some probably fail, and be able to progress from that, and then building on those successes to start simplifying the environment.
Can blockchain be applied to improve cybersecurity?
Cybersecurity is a really interesting aspect to distributed ledger technology, and I'd use distributed ledger as opposed to the word blockchain, but there are different aspects that certainly overlap. There are a number of different ways that we believe this technology can apply to cybersecurity. First, because every time you add a node to this environment, it just automatically adapts and understands how to fit into the node and how to share information. That means the resiliency of this environment, of any network, can be expanded horizontally, potentially infinitely. You could just keep adding nodes so there's no single point of failure. And the different methods for governing something called consensus and making sure that whoever is in charge of the network for any particular transaction has a failover path and there's always somebody else who can do a transaction. That's part of the beauty of this technology and why it's been widely embraced. There's no single point of failure here. You can always add nodes. A node could disappear, even if it's an important node, and another one will immediately pick up. So that's point number one. Point number two is the data is processed and validated in multiple different locations. So if you have a potential corruption, if you have a malware compromise of a node and it tries to take data that it should not take, there are many other nodes that perform the same validation, and you can have different types of mechanisms that say either it has to be unanimous consensus, every node has to agree, or the transaction is rejected, or some other different variant of that. And if a node continues to perform badly, you can actually penalize that node and take it offline, and that's built into the protocol. So if anything is potentially compromised, you have other ways of validating that same information in other locations, and that's really powerful because today that would mean rebuilding the same exact application in a different place in a different technology, and that would just be very cost prohibitive. And the second way is this whole hashing and cryptography mechanism, where it basically you are using math to validate data and say that if that data is ever changed in any manner, then it will not match to that hash code. Okay? And this, we are looking at using this for a couple of control environments. We're looking at using it to validate potentially configurations of our systems. So if we have systems that when they come up, they configure in a certain way, they will verify the hash of that configuration, every time they come up. And if that hash is ever changed or if the configuration doesn't match, we'll immediately know that that system was compromised. This is a whole new way of validating and verifying controls, and this increases greatly our cyber protection.
Rob, thank you very much.
Thank you very much, Emily.
Thank you for watching.